In this video, we're going to be talking about remote access, which is the practice of accessing a system remotely. Okay, so why would I want remote access? Well, have a look at this little VT right here. This is showing me finding my keys, which are conveniently located right next to my keyboard for this little clip, and then heading out to the garage. Now, my garage isn't far away, it's just over there a little bit. And it's not hard to get to. I just get my keys out, I go into the garage, and then go and pat it on the head like this. Just pat my server on the head, that's all I'm doing here. I mean, obviously you wouldn't pat your server on the head because that does nothing. It does nothing at all. But imagine having to do this properly, like getting a keyboard, getting a monitor, dragging them outside, getting them plugged in, and then doing stuff on my server because I can't do anything from my PC right here. That's a pain. I mean, I've got an Intel NUC and a Raspberry Pi down there too. I don't have monitors plugged into them. I don't have keyboards plugged into them. So if I wanted to do anything on them, I'd have to plug those in, right? Well, no. This is where remote access comes in. So you'll have heard of remote desktop for Windows. We're going to be using something called Open SSH to access our Ubuntu server. So that Ubuntu server we set up in the previous video, that if you haven't followed, you won't have, but I'm sure you can figure it out, or go and watch the video to figure it out yourselves. We're going to be accessing that remotely. Doing this means that we don't have to spin up the VM every single time with a windowed mode. So when we launch our VM at the moment, a little window opens up and we can do stuff in there. That's directly accessing the machine. What I want to be able to do is spin up the VM in headless mode and then access it via a different terminal, i.e. from my PC itself, rather than having to go into the VM window. Now, you might be sat there thinking, well, what's the point in that? The VM is right there on your machine, it doesn't matter. Well, yeah, I mean, you're right. But again, talking about that server that's just out there, or my Intel NUC or Raspberry Pi's down there, I don't want to have to plug a monitor and keyboard in every single time. That's just a pain, and it's inefficient. You know, you need remote access. If you're working in the cloud, you haven't got access to the physical machines. You haven't got access to the cloud machines. You've got to use remote access. So let's get into how we set that up. I'll be continuing with the VM that we set up in the last video. If you don't have this VM, go ahead and set it up using the last video tutorial. If you have a server available that you have direct access to and don't have OpenSSH installed on, then you can use that too. If you do have OpenSSH installed, you might just want to skip forward a little bit. But yeah, let's go through this process. To install the package for OpenSSH, we need to use a tool called apt. If you're using a Red Hat-based system, you'd use something called DNF or Yum. There are other options available, such as Pacman for other base systems. There's a few different package managers, but for us, we're going to be using apt. Now, I know the package is called OpenSSH Server. If you didn't know that, but you knew you were looking for something called SSH, then you could search for a package using apt search. So we're going to go ahead and put apt search SSH. This will give us a lot of output, and to be honest, I can't scroll up and down here. If I was on a physical machine, I'd be able to do it, but for some reason, in VMs, we can't. So let's refine that a little bit. So I'm going to press up to bring up the previous command, and I'm going to pipe the results, that's that vertical line, into something called grep. Now, grep is just a pattern matcher. It will search for a pattern that you give it. In this case, I'm going to be searching for server because I know I want the SSH server. Now, let's search for that and see what comes up. Okay. Now, I can still see some stuff going off the top of the screen there, but I also, because I know the name of the package, I can see the package that I want, and that's just here. If you look where my mouse is hovering over at the edge of the screen here, then you'll see OpenSSH-server, and then just below it says Secure Shell SSH server for secure access from remote machines. Well, that's exactly what we want. Let's go ahead and install that package. So to do that, I'm going to clear the screen with Control-L. I'm going to put sudo apt install OpenSSH-server. Now, I could automatically say yes to the next question that's going to come up by putting -y on the end. If you are only installing one package, it will automatically just install the package. However, OpenSSH needs a few extra packages, which you'll see in just now when I press enter, after I type my password. And as a result, it's asking us, do you want to continue? So you can see here the following additional packages will be installed. librap0, OpenSSH-SFTP-server, and SSH import ID. We need those packages, so yeah, let's just type Y and hit enter. It will give you some suggested packages and things like that too. I'm not bothered about those suggested packages, so I can just ignore them for now. Now that SSH is installed, let's try and connect. We should be able to connect right away. So let's try and do that. So I'm just going to drag this window over here and bring in my Windows terminal. Just before I do this though, I want to go over a couple of the different options that are available for us to connect via SSH. So the first one that I'd recommend having a look at, but maybe not using day to day in my opinion, is something called PuTTY. Now PuTTY has gotten me out of some horrendous situations in the past, but nowadays there's other tools available that I personally think are better. That doesn't make PuTTY bad by any means. It's just not really suitable for me anymore because I like to have many terminals open in many tabs, and PuTTY doesn't support tabs. There are tools that wrap around PuTTY, but I prefer other options, which I'm going to go into now. So another option would be PowerShell. Now again, PowerShell doesn't support tabs, but you can get tools that wrap around it that allow it to support tabs, such as the Windows Terminal. The Windows Terminal is an app from Microsoft that will allow you to launch PowerShell within it, and you can have multiple tabs open. So I think PowerShell from Windows 10 onwards supported the SSH command, and that can be used just to SSH onto a server that running Linux, which is really useful. If you don't want to use PowerShell, then the other option available to Windows would be something called Windows Subsystem for Linux, which is essentially a Linux system running within Windows. So you can just fire up the Windows Subsystem for Linux and you get all the commands available to you on a standard Linux system, or Linux-based system, I should say. So you can get Ubuntu, you can get Debian, you can get many different distributions of Linux on Windows via the Windows Subsystem for Linux. You just go to the Microsoft Store, have a look for those distributions, and you should find one in there that suits you. Another option is something called MOBA Xterm. Now, if I remember rightly, this sort of uses a wrapper around PuTTY. Again, could be wrong, it's been a while since I've used it, and I don't really use it anymore. My personal preference is I've got Windows Subsystem for Linux installed. I launch that via the Windows Terminal, which allows me to run multiple tabs. And that way, I can just use it as though I'm using Linux directly on Windows. It's meant that I don't have to dual boot Linux and Windows anymore, which means having both operating systems installed on my machine. I can actually get rid of Linux now and just use Windows with Linux essentially running on top, which is really useful. So, as I say, I'm using the Windows Subsystem for Linux. So I've actually installed Ubuntu, which is my Windows Subsystem for Linux. And then I've got the Windows Terminal here, which allows me to have many tabs and access different terminals from here. So how do we connect via SSH? Well, we type the command SSH, then the username we want to connect to. So in my case, Drew, as you can see in the VM just here. Then we put an @ and then the IP address. So what's the IP address? Well, we're going to have to go back to the VM and put IP A. So I'll press enter on that and you'll see all this noise appear on the screen. I'm not going to go through every line of this because this is down to networking and a little bit more in-depth stuff there. But what I will say is we're looking for something that looks a little bit like 192.168.0. something or 192.168.254. something or 192.168.1. something, or maybe even 10.0.0. something. So your private IP address can vary depending on your network provider and many other factors. In my case, it's this one just here. I don't know if you can see this just here. I should have had some sort of prompt, but I'll try and put something on screen. And you can see here it's got 192.168.0.202/24, then BRD and some other numbers. We want that 192.168.0.202. This 127.0.0.1 just here, this is not one we want to connect to. That's the local IP address for the machine. So if I tried to connect to that, I would actually be trying to connect to my own PC on my machine. Because if I do it here, let me just get rid of that command, IPA, you'll see here I've got low, and I've also got that same IP address here. However, on my PC, I have a different set of IPs, 172.19.141.1. So it can vary depending on your machine, depending on your network provider, depending on how your network's set up. So I can't tell you what your IP is going to be. What I can tell you though is that you should have something that says something like ETH0. As you can see, I've got that in my VM just here as well, ETH0. It might be ENSP1 or ENS3 or something like that. That's your network adapter's name as identified by Linux. Generally speaking, ETH0 is used, but more modern machines sometimes have something different. So you might just see something very slightly different there. There are other ways of getting your IP address. However, I can't go into every single one here because it would make this video much longer. So I'm going to go with IPA for now. So IP space A, press enter, and you'll see that. If you want to refine it a bit, again, just pipe it into grep and put inet, and that will just give you a slightly nicer view. It will get rid of all the noise essentially. So you'll see now that we've got this local host at the top, which is 127.0.0.1. Then we've got an INET6, which is IPv6. This is a newer type of IP addressing, and that's what all these ones with colons are using, basically. They're IPv6. And then we've got our IPv4 address, which is this 192.168.0.202. So that's a quick overview of IP addresses. I don't want to get into networking too much today because that's a whole tutorial series of its own. So back to how we connect. SSH, username, Drew, at 192.168.0.202. So if I press enter now, I'll get asked the authenticity of the host, the IP address can't be established, and then ask me if I'm sure that I want to continue connecting. I am sure, so I'm going to type yes. You'll only see this the first time you connect to this machine, so we'll do that. It will then prompt me for the password of the user on the VM. So I use the password that I log into this with. So I'll type my password, press enter, and there we go, we're in. It will give us the welcome message, and then we can see now I've got Drew at demo 1. Let me just clear the screen with Control and L. So I've got Drew at demo 1 just here. And again, you can see on the VM, Drew at demo 1. So we know we're on the same machine. I can prove it by IPA grep inet, just like I did on the VM itself. And there's the IP address again. I'm on the VM via SSH. So that's SSH done. We're connected. Again, I can just prove that a little bit more by running the command top on the SSH connection. Top is just like a task manager for Windows. It just gives you a lot of information on the processors running, the uptime of the machine, the load average, and more. So if I go back to the VM again and type W, which will give us an output of the users connected, you can see the second user down on PTS/0, then it gives you my IP address. And right at the end of that, you can see the word top under the column of what. So what is, what command am I running? Well, the top one has W because I've just run that on this machine. And then top is what I'm running via the SSH connection. So we know we're definitely on that same machine. So that's how to connect via SSH. I could end the video here, but maybe you want to look at how to connect without a password so you can not have to require a password to log in, making it a little bit safer to log in for starters. And secondly, it allows you to turn off password authentication, meaning that no one can ever enter a password to get onto this machine. It means you need something called a public-private key pair to log in. So how do we do that? Well, I'm going to open a new tab just over here in Windows Terminal, or you may open a new terminal or a PowerShell. For example, I just want to show you how PowerShell works in exactly the same way. 192.168.0.202. I need to put my username in there as well. Drew at. So if I do that, type yes. This is obviously asking me again because I'm now on Windows, not my Windows subsystem for Linux. I'll pop my password in, and there we go. I'm in. Drew at demo 1 via the PowerShell. So, like I say, there's a few options here. I'm going to open a new terminal on my subsystem for Linux though. I'm then going to type SSH-keygen and press enter. This will say it's generating a public-private RSA key pair. Enter the file in which to save the key. This is the default, and if you try to connect via SSH, this is the first file it will check unless you provide one to it. I'm not going to use that one because I already have a private key and public key set up under that file name. So I'm going to type a new one in, which is home drew/.ssh/demo_RSA. It doesn't have to have the word RSA in it. It could be called anything else. You could call this "Here is my awesome key." You can call that whatever you want. In fact, let's call it that. It's a bit of a long name, but let's do that just to show that it works. You can call it whatever you want. And next, it asks you for a passphrase. Now, this passphrase is to unlock the private key, not for connecting to the machine. I'm not going to enter one here. I'm just going to press enter and then enter again. That's the public-private key pair generated. We can have a look in ls home Drew, or if I want to stop typing home Drew, just get rid of that and put tilde/.ssh, and we'll see that there. I just want to clarify what I'm talking about here. So /home/the username is the same as typing tilde/. So if I put ls home Drew, you'll see those, and they're just some files that are in my Windows subsystem for Linux. And if I type ls tilde, you can see the same. You can also do tilde/. And that gives you the same result as well. So yeah, it's just shorthand, that's all it is. So I'm going to clear the screen again, and we'll have a look in ls.ssh, which is where we save that file to. So here it is. Here's my awesome key, and here's my awesomekey.pub. So this is the public key. This is the one we give to remote machines, and this is the one we keep on our machine and never, ever, 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 ever share with anybody else, ever. So how can we connect using this now? Well, let's do this. SSH, copy ID, Drew, the username again, at the IP address. And then we say I want to pass the identity file through, and that identity file is going to be that.pub. If I didn't put the -i and then the name and then we pass the identity file through. If we didn't do that, it would automatically pass the ID rsa.pub through. I don't want it to pass that one through. I want it to pass the one we generated in. So I'll put -i // here is my awesome key.pub. So all I need to do now is press enter. However, before I do, I just want to show you where this will end up. In fact, let me go back onto the SSH connection because I can highlight it a bit better. So if I go into here and put ls-a /.ssh, there is no SSH lock. It's not finding anything. So if I just check without .ssh, you can see, yeah, there's nothing there. There's absolutely nothing. There's some hidden folders and files, but there's no .ssh folder. What it will actually do is it will create a .ssh folder and then create a file called authorized keys. And that authorized keys file is where this will be copied to. So I'm going to press enter on here. It will prompt me for my password. Sorry, 1 second. That's my fault. Put the -i and the file name before the username and 192.168.0.202. So that was my fault. Then we enter our password. And you can see here, number of keys added, 1. So great, I'll clear that screen. We'll go over to the VM again, and now I'll list the contents of this directory. And you can see .ssh now exists. So let's have a look in there. And there's that authorized keys file I was just talking about. So let's have a look in there using the word cat at the start instead. Cat just stands for concatenate. You can merge multiple files together into one using this command, but you can also just look at a file quickly in the terminal using this command. So I'm going to do that and press enter. And as you can see, there is a lot of letters with SSH-RSA at the start and Drew at DrewPC at the end. This is our public key, and I can show you that on here now. So I'm going to type cat /.ssh. Here is my awesome key.pub. And you'll see here, this is exactly the same string that is in here. So my public key ending 8SBM0 equals is exactly the same as this one here, which ends 8SBM0 equals. So yeah, there you go. So that public key has now been copied across to here. And now if I try and connect using my SSH command, 192.168.0.202 and press enter, it's going to prompt me for a password. Because as I said, it will default to that ~.ssh/ID_RSA and RSA.pub file. How can we get around that? Well, simple. We just pass that -i in again, like we did with the copy ID command. So we do -i ~.ssh. Here is my awesome key. And we don't do the .pub because we're using our private key. We're going to use that to say, hey, we're connecting using this private key. And then the public key on the actual remote machine, or the VM in this case, will basically verify that. That's why it's a key pair. It basically, we pass the private key and the public key is used to verify that private key. So we'll press enter on this. Bang, there we go, we're in. No password required. So that's now passwordless authentication enabled. Great, that's good. But you may have also noticed, if I exit out of here, that if I press up a couple of times and go to this command and press enter, I can still enter a password. How can we disable password login? Well, that's fairly easy. All we need to do is we go into sudo vim etc sshd_config. This file is the config file for the SSH service. Vim is a text editor, and sudo again gives us super user access. We need super user access to be able to edit this file because of where it's located. So I'm going to press enter on that and put my password in. And then I'm going to scroll down. There's a lot of options here. We could uncomment most of these, but these are all the defaults. So it gives you the defaults and then we can change them as we require. But we're looking for something called password authentication, which is just here. There we go. Password authentication, yes, it's yes by default. And as you can see from this, to disable tunneled clear text passwords, change to no here. Well, we absolutely want to change that. So let's change that to no. We'll press escape :WQ. And that will allow us to write and quit. By the way, just a quick crash course on Vim before I do that. I edited the text by pressing I or insert to go into insert mode. You know you're in insert mode because it says so at the bottom here. To get out of insert mode, you press escape. Insert mode just allows you to type text. If I try and type something now, you can see it's actually doing other things. Vim's a really powerful text editor, so you need to get used to using this. But yeah, I to enter insert mode or insert to enter insert mode. I can then make any changes that I want. Then I press escape to exit insert mode. As you can see, it's disappeared from the bottom here. And then :WQ. :WQ says, I want to write and quit. If you wanted to quit without saving any changes, you just put Q!! And that's a quick crash course on Vim. So I'll write and quit. So I've changed the configuration, but if I try and connect Let me just exit out. I press Control D then. Control D is the same as typing exit. I will press up to go to the previous command, press enter. Oh, it's still prompting us for a password. Well, that's because we didn't restart or reload the SSH service. So that's all we need to do now, just to finalize that change that we've made. So I'll do systemctl, which is what we use to restart or reload services. We can also use it to enable and disable services and things like that. I'll then type the word restart and then SSHD. I'll press enter on this and, oh look, it's asking us for a password. So I could type my password in here, or I could go up and put sudo at the start. You'll see that this sort of thing happens a lot. You'll either get a permission denied or you'll get prompted for a password. So I'll press enter. Same thing, get prompted for a password, but I'm running it as sudo. I could have achieved the same thing by just entering my password. It's just telling us that you need to authenticate to restart the service. I just thought I'd show you that before moving on. So I'll press enter on that. Now the SSH service has been restarted. Brilliant, that's good. The thing is now we've not lost connection. Our other one's still connected and that's great. So we don't need to worry about that, but I will just disconnect real quick. I'll clear my screen again and now I'll press up and press enter. And now we're getting permission denied because of the public key being required. Brilliant, that's exactly what we wanted. So if I just press up a couple of times, we can go to the previous command with the private key, press enter, and there we go. Disabled password login, enabled public key authentication. Now, no one can ever log into this server with a password. They have to have a public key on the server to be able to access it. They need a private key that's valid and then a public key that's matching that private key on the server. One other final thing I'll quickly show you how to do in the SSH configuration is to change the port the service is running on. Some people like to do this. Personally, it doesn't bother me too much because I'd put a firewall in front of my machines. But here's a quick example of how we can do that. So if I do sudo vim etc ssh sshd_config, go into that file again, and then go back to the top of this file, you can see here the word port 22. So ports are used to access particular services. Again, this is a networking thing. I don't want to go into it too in depth, but just to give you a quick idea, SSH in general runs on port 22 by default. HTTP or the web runs on port 80 by default, and HTTPS or the secure web, when you see secure in the top of your browser, so when you've got an SSL certificate on a website or something like that, runs on port 443. There are a lot of default ports. I'll drop a link into a Wikipedia article in the description below so that you can have a look into some of the defaults. And yeah, so ports are just something you attach to the end of an IP to be able to access a particular service. That's essentially what it is. It's a lot more detailed than that, but this isn't a networking video, so I won't go into any more detail than I just have. Let's jump into insert mode. Delete that comment at the start. Let's change it to port 2222. I'm going to right and quit that, and then I'm going to type systemctl restart sshd, and just to show you it does work this way without sudo, I'll just type my password in. I think I typed that wrong. Yes, I did. So I'm just going to run that again. There we go. Authentication complete. And you can see here, authentication failed. So actually it was quite useful because you can see what happens when you fail to type your password incorrectly. Access denied, you cannot restart the service. So I entered it correctly this time and the service has been restarted. Now, how do we know what port it's running on? Well, a quick way we can check. There are other methods, by the way, on top of this, but just a real quick way we can check is we can do systemctl status or status, depending on which part of the world you're from, and then SSHD. Press enter on that, and we can see that the service is active and running. It has been for 28 seconds at this time. And if we just look down a little bit further, we can see the port it's running on is port 2222. This here just says it's listening on every single IP that's available on this server. So it's listening on IPv6 as shown here and IPv4 as shown here. Servers can have multiple IP addresses. So in that case, I would be able to connect to any of the IPs. As we can see, I've not been kicked out because the connection's already established. But if I exit out, I'll clear my screen again and then press up and enter. Even with my public key, I'm getting port 22 connection refused. That's because we just changed the port. So if I press up and then on the end of this command, put -p 2222, because now we're entering a different port. The default is port 22. So when you use the SSH command, it defaults to port 22. Well, now we want a different one. So I'm going to put -p 2222 on the end and then press enter. And there we go, we're in. That's basically it. That's a bit of remote connection for you, remote access. So there we go. We've got it running on port 2222. Now, I won't be leaving it on this. I'm going to flip it back to port 22 in a minute. And some people would say, oh, no, you should leave it on port 2222 or a different port altogether because it's for security reasons. Personally, I think that's nonsense. I don't see the point in changing the port because pretty much any port can be scanned by a tool called Nmap, which will allow me in turn to check what service is running on that port. It's security by obscurity, which is essentially going, hey, don't look over here, because, you know, that's not where it's set up. Look over here instead. Or it's It's not really security, it's just changing the defaults. And with a tool like Nmap, as I say, I can just scan your network and find out what ports are open, and then in turn scan those ports to find out what services are running. So security by obscurity, yeah, maybe it works for some, but personally I don't see the point in it. You're better off configuring a firewall, getting things like a web application firewall. There's loads of different tools that will give you better security than just changing the port of a service. So what we can do now, I'll really quickly finish this up, is I'm going to shut down this machine. So sudo shutdown -h for halt, and right now you can put a time on the end of this if you wanted to, and I'll show you what we can do. Because imagine having 10 VMs running and you have all those windows open. Well, I don't want that. You may also have a server somewhere else that you just can't see. So this is an example of what you might do then. Well, you've got here a little drop down menu and then headless start. Headless start does not open a window. You'll see here it starts to show up when it's booting, which you can now see. And then once it's booted, we'll be able to access the machine still without having to open a window. So we'll just let this boot up. One way we can test that it's up is by pinging the machine. Pinging it's like a bit like sonar. So we can do ping 192.168.0.202. So you just type ping and then the IP address and then press enter. And you'll see no response or destination unreachable until it is reachable. So yeah, actually the network came up quicker than I expected to. So we're now actually seeing a response. We can see 64 bytes from the IP address and then some other information you don't need to worry about right now. So yeah, we can see that it's up. So I'll press Ctrl+C to cancel that ping. And then I'll do SSH Drew at 192.168.0.202 on port 2222 with the identity file of ~/.ssh. Here is my awesome key. Enter. And we're in. Now we don't have all these windows open for the VM. We can close all of this off and we now just have this terminal where we can access that VM. And we can do everything we would have done before. So I can do @search Open SSH, for example. And there you go, there's the response. We can do everything we did before, but we've got remote access. And that's it. And there we go. That's everything. We've done. We've done remote access. We've done installing packages. And we've done a little bit of configuring of the SSH service itself. There's a lot more you can do with it. Obviously, go and have a play, look through the manual pages that I showed you, and just have a look around. You'll see a lot more information available. As I've said in the previous videos, I'm not going to be covering every single possible option in every single service because we'd be here forever. And no one wants to be here forever, right? You want to just crack on and start doing stuff on your side. You don't want to sit and watch me all day. So yeah, go and have a look, have a play. In the next video, we're going to be managing devices via the operating system. And I said that in the last video, but I forgot that I needed to do this video. So it's kind of rolled over into the next one. So yeah, I'll see you over there. There are tools that wrap around. Just punch my mic.